Hey everyone, it's great to see that so many serialization enthusiasts are in the audience. So my name is Viktor Klang and I work as an architect in the Java Platform Group at Oracle. And I'm going to talk to you today about serialization. And serialization has a rather long history. And there are many things that you could say about serialization that may or may not be true. For me personally, some of those, or perhaps all of those, might be true. It's been a long time. Serialization has been in Java since 1.1, so since 1997. And I think it's important that we remember what time that was. This was when the internet was largely unencrypted and everything was more fun. And what we were trying to achieve at that time was the remoting and persistence of objects. So being able to take objects that you had in one VM and transport them to another VM and preserving a lot of things. And also remember that back in those days, the term distributed objects was a really hot buzzword. There were even best-selling books on the topic. And if we recall this context, then it's not that weird that we ended up with something more akin to teleporting objects between different machines. The problem, though, is that it takes a long time to understand the implications of such a thing. And we've been learning new things about the implications over several decades. So when you create something new, it looks cute. It's fun. You can do some awesome things. But then, as it inevitably goes, it grows up. And I think it was my colleague Stuart Marks who said that still looks cute, though. So I had to add some lasers to it as well. So back in, and this is pre-pandemic time, so back in 2019, Brian Getz wrote a bit of a write-up on the topic. I'm not going to go through that in full here, so if you're interested in learning more about what he thought at the time, go to that link and read that document. It's very interesting. All right, so what are the problems with serialization? It sort of pretends to be a library feature, but it really isn't, because it needs support beyond the standard library itself. It sort of pretends to be statically typed, but it really isn't. There's nothing that tells you that you typed write replace wrong, because it's a magic method name that you need to know, and you need to know the signature of. So the compiler won't help you. And it's also woefully imperative, because you have to create these methods called read object or write object, and you need to mechanically output things from the object itself. And since you're mechanically writing those things, it's very tied to the encoding or the format of Java serialization. So if you wanted to represent your object as any other format, then you would have to do something differently. And the stream format in itself, we could talk for a long time about that, but there has been an explosion of different types of wire formats over the years. So everything from XML to JSON to comma-separated values or whatever it might be, right? There are so many things that you could choose from. So the question is, when do you choose what and why? And some of the consequences of the implementation of serialization is that we undermine encapsulation. Because remember, when you create an object, you're creating that through a constructor. But then when you need to send it somewhere else, you're taking that object as it is at that time, not at the time of construction. And you're sending the representation as it is over to somewhere else. And then you need to recreate it in its new form on the other side. But it doesn't go through the constructor. So now you need to create a new object with special means and bypassing the constructor, and then try to put everything where it belongs inside that object. And that undermines security because we're not going through the same validation rules that you do when you call the constructor. And I think everybody who's been working on OpenJDK at some point has realized that almost everything you do, you need to consider what does this have to do with serialization, or does it impact serialization in any way, shape, or form? Does it change the representation silently? And you need to consider it at all points. So this really complicates library maintenance. Having to have this external format that is a part of a contract that you need to take into consideration. And also remember that when you test these things, you need to test a previous version against the new version, because you only have the new version inside your running tests. So if you really want to make sure that you haven't changed anything in the serialization aspect, you need to test something written with the previous version and read it in the new, and vice versa. But most importantly, I think it really is the undermining of the object integrity. So how many of you have actively used serialization before, like written read object, write object, read replace, write, or read resolve, write replace, and all of these? Yeah, so a fair number of people. I have been on the JVM for 25 years, and I can look at a class and still be uncertain about what gets called first. What gets called first? Is it read resolve, or is it read object? Or like, it's really hard to just, as a code reviewer, look at the code and say, this does what it's supposed to do. Because there is an order embedded within something that has no way of telling you in the code what order that is. And also, since deserialization is not going through the constructors, you have to consider the fact, do you have a mismatch between the constructor validation and reading the object validation? You might even have some more stringent validation on the deserialization part as well. So Brian and Stuart, they gave a presentation 6 years ago called What We Hate About Serialization and What We Might Do About It. I encourage you to, if you are an enthusiast of serialization, I encourage you to have a look at that and see what they had to say. But we have spent a fair amount of time thinking about this problem and where we would like to take things next. What is the thing that is serialization, but having learned things over 3 decades? So, small summary while we're here. Main challenges: extra-linguistic. It's not a part of the language, but it sort of is, but it sort of isn't. You have transient, which impacts serialization, but on the other hand, it's hard to know what it is. It's everything and nothing. We extract the state from objects by scraping them. So the class author is not necessarily in control of what gets scraped. And we're also doing quite a bit of magic accessibility busting, right? Because you could have defined your class inside your module somewhere, and then something else needs to be able to get access to that and read its state. It's worth remembering that even if the, hey, let's create a new instance without calling the constructor is a challenge in and of itself for Java serialization, but many other wire formats use similar techniques or the same strategy in order to rematerialize an object somewhere else. Another challenge is the monolithic nature of it. And I'll show you with some graphics just what that really means. It's hard to have a look at serialization logic and know what happens at which stage, because you're essentially just writing an object and then you don't know what happened. And it's also really, really hard to use correctly, because your definition of correctly might be different for each use case. So some things might be extra sensitive and some things might be, hey, it doesn't matter. But how do you know? And when does that change? That means that it's really easy to create security risks. So Brian has this model. I'm calling it for now, just this is a caveat, this is my name for it, is Brian's model of how did we get here? And as you've been in the industry for a long time, you realize that this applies to a lot of software projects. You start out with, oh, this is going to be easy. This is even going to be fun. This is an interesting challenge. And then you realize at some point that there were a lot of details that you only had to discover, and now it's not that fun anymore. And the problem is that it tends to be an iterative process of finding something you didn't expect, trying to come up with a solution for that, and then you're going to find the next thing that you didn't expect, and rinse, repeat. And now you've created something, and you have climbed the mountain and arrived at the peak of complexity where you've addressed all the things that you discovered along the path, but you've created something immensely complex. But it works. So you may be very tempted to ship it, because now you're done. The suffering is done, let's ship it. The problem, though, is that software isn't done when you ship it. Software is done when it isn't used anymore. So optimizing for the initial shipping is not necessarily the best thing to do. So how do you get safely down from the peak of complexity? Well, the easy way is to not. Let's just ship it. And I think you could say that this is the path that serialization took. And this complexity has caused several decades of suffering. And as I said before, this is not something that is isolated to language evolution or standard library evolution. I think this is blanket across all software projects. And once you've shipped a piece of that software and you've lived through its maintenance cycle, you're very tired. So back to serialization and how this is moving forward. I think most of you have used records in the past. Let me know if records is not something that you have been working with for a while. It's important to know that there are some interesting down payments that records did. So they have, in just by its very shape, another means of serialization. So once we have this record signature or its state, we know that when we deserialize that, we're always going to go through the canonical constructor. So there is an important symmetry between creating the record and extracting its components and then recreating it using its components. And an important part there as well is that since we're going through the constructor, we're using the same validation no matter if we're creating it using new or whether we're creating it from deserialization. There is a huge difference there because if you have one constructor, there's only one place of putting your validation logic. So there's no risk for it to get out of sync with the deserialization validation logic. So there is a semantic contract of records that we can use to make serialization of records safer. The problem, though, is we cannot necessarily do that for classes yet. So if we can pattern match on a record to get the values out, then we can call its constructor again. So let me show you what that looks like. So here we define a record type called point. We have an x and a y coordinate, and we create p1, which is a new point with x1 and y2. And we can then switch over, we can pattern match against p1 here and get the x and the y out, and then we can recreate a new point that has the exact same values. So this we have called a record pattern, and it's possible to see the link with creation, deconstruction, recreation. Simple things. So in a future, we might have the same thing for classes. So let's say that we define this as a class instead of a record. We have X and Y as fields. We create our constructor as we usually do. And then we have a sort of a signature here. We have the parameter list of the constructor, which gives us the inputs to the point. And then we copy those into the objects. We've done this for decades, right? This is super useful and common things. But now let's introduce something slightly new. So imagine that we could declare something that was the complete inverse of a constructor. So we have the same shape here, but instead of those being parameters in, those are sort of output parameters. And they have the same shape as the constructor. So remember, in the case of the record, you have a constructor with a signature, but you also have this record pattern, which has the same signature. And then we do the inverse. We take the state that we have in the point, and we pass that to the input parameters, or the output parameters. So this is trying to piece the story together here. So one of the big costs with serialization is supporting arbitrary object graphs. And it is sort of like teleporting an engine and have it appear somewhere else still running. It's a really difficult problem to solve as a general thing. And one of the biggest troubles is cycles in that object graph. And Stuart Marks has an excellent presentation on this topic from last year, if you're interested in seeing the intricate details on where reconstruction of circular graphs could go awry. So deserializing objects through constructors changes how you need to reconstruct the objects, because you need to know things before other things. So by passing an object into a constructor, that object needs to be fully known. So it does impose some restrictions on how you can represent arbitrary object graphs. But it's also important to remember here that a lot of different wire formats do not support circular graphs anyway. Like, how would you represent a circular graph in CSV or in JSON? You can encode it yourself and resolve it yourself, but the format itself does not support that functionality. All right. I've been saying a lot of negative things about serialization for like 15 minutes or so, but there are more grievances. Let's say you have an object hierarchy or a class hierarchy, and class C implements serializable. Now, anything that extends C is also serializable. So now you're imposing this contract for anybody in the future that is extending this class. And you would have to know that the parent class is serializable, because it's not going to tell you. So there is this, hey, I'm creating a subclass. I never intend for this to be serialized or sent anywhere, but I still need to do something in order to make sure that that doesn't happen. But it gets even worse, right? Because imagine that A is serializable. Now everything inherits this. So I think it's pretty safe to say that after 3 decades, marker interfaces are not the way to implement this. So what can we do? So let's look at the anatomy of Java serialization. So we have some class, we have instances of that class, and we pass those instances into write object, which turns it into some data, which also turns it into some wire format, which also is then turned into the data again and then passed through read object on the other side and rematerializing it. And this is sort of the serialization box. It's really difficult to know what's going on in there. And it also makes it really tricky to switch out whatever format you would like to have instead of just Java serialization. What if you wanted to do XML or JSON or whatever wire format that you need to use for a specific use case? So how do we descend from the peak of complexity when it comes to serialization. I think this is the best way for me to visualize how we're thinking about this. So first and foremost, I think it's really important that class authors are in charge of their external representation, because they are the ones who have to maintain it and evolve it. I think it's really useful to package up how do we take an instance of that thing and turn it into some sort of shared representation. How do we pick it apart and how to represent whatever we picked apart? And then on the other side, we need to take that structure and we need to recreate the object, right? So that's something that we should have as a common construct. And then again, the class author needs to be the one who validates the object, because that's the only person who knows what the correct validation rules are. But that means that the wire format now is clickable. We haven't said anything about the wire format. And we haven't said anything about I/O. So now, instead of it being opaque end-to-end, we are now able to interject things into the middle of this sandwich, if you so will. So one of the core ideas, as I said, the class author needs to be in control of the external representation. And the way that we're thinking about this is, hey, the humble parameter list that everybody's been using for many, many decades is a really nice way of being able to specify types, names, order, which tends to be the things that you have in a serialization format. You have types, names, and an order, typically. How do we create things? Well, we already have means of creating things. We have constructors and static factories, so let's lean into that. They both have parameter lists, and they both are able to give us object instances. And on the other way, how do we get the components, the values, the structure out of these instances? Well, if we have deconstructors, we have patterns that allow the class author to decide, okay, this is how I expose my structure, then the class author is still in charge, but we now have a standardized means of extracting values out of classes. So you can think of the external representation as a projection of that object instance as data. So it's not necessarily coming up with something random like, hey, I just created a socket and gave that to you, but it's really about exposing the internal structure. So how do we deal with the fact that serialization is extra linguistic? We use language constructs, right? That would be a good way of dealing with this. Instead of just making it a pure library feature, I think it's better to just, hey, let's use what we have. So imagine that we have this point class that we talked about before. Imagine if we could just say that this constructor should be used when we want to recreate instances of this type. So the annotation here is just a declaration of intent. And on the deconstructor side, we say that, hey, when you want to deconstruct and create the structure of this object, this is the thing that I want you to use. So let's think of this as the designated unmarshaller, and we have some form of schema. We have an owner type, and we have parameter types. We have parameter names. There is an order. And on the other side, we have a marshalling schema and a designated unmarshaller. And the interesting aspect here is that this will typically be the normal case, right? You want to have a match in signatures between how you create it and how you take the structure and expose the internals. So you can, in the same VM, go back and forth. But there might be cases where you only want to be able to export something, or you might only want to be able to import things. So it's still left as a choice to the class author. And how do we deal with the access violation of scraping fields? Well, we just need to deal with access control, right? So instead of forcibly going in and scraping all the instance fields and their values, what if we just allow people to say, it's okay if the marshalling aspect of the program has access to the internals of this class? It's still in control of the class author to decide, hey, I'm giving you access to look at my private constructors and private deconstructors. So it's an opt-in, which means that there is no way for somebody to get access to your stuff that you haven't chosen to do so. All right, so how do we deal with the fact, because serialization has a lot to do with versioning, right? Everybody, what's your favorite serial version UID? Everybody has one that they reuse. So, interestingly, what if we treat structure as version? So let's say that you used to have a packed representation of this point class. So you packed your x and y's into a single long, and you use that as your external representation, and you changed your mind. What if you could just deprecate your previous constructor and you were to just create a new one with your new preferred structure, right? So we could have multiple constructors at the same time if we want to be able to read things that were written at a prior time. So those could be several versions behind. But we only want to have one canonical way of serializing or creating the structure, and now this is the current structure of the thing. So we have a single, or at most one, marshaller. So how do we deal with inheritance? So if we want to create a great point that extends point, we need to be able to ferry information between superclass and subclass. And we've done this for 3 decades now, where we call super. This is how we delegate to the superclass. But now we want to be able to delegate to the super in reverse. We want to be able to get the structure out of the superclass instead of putting structure into the superclass. And this is work in progress. So the current syntax looks something like this, where you pattern match against your supertype. And this is subject to change, of course, but it's the inverse of calling the superconstructor. So that means that we can now go and pass information into the superclass, and we can get information out of the superclass. So now we've seen how we have decided to use language features to try to represent what it means to create and not to destroy, but deconstruct structure. So we're using annotation to signal intent. The class author can say that this is the constructor I want to use for this purpose. We're using constructors and factories. We're using deconstructors for state extraction. And class authors are still in charge over their classes. And of course, there's a bit of caveat here, right? Because you don't want to have mutable state exposed as your structure, because then you get this sort of spooky action at a distance if those things change mid-flight. And of course, there's a lot of benefits to this, right? If you think about it, no transient, no serial version UID, no serial persistent fields, read object, write object, read resolve, write replace, no magic constructorless creation, no field scraping, no weird cycle issues. There's so many benefits that I was struggling to fit. You see, it doesn't even fit on the page. So I think that's a good signal here. So serialization is monolithic, and I think, as you saw before, the solution here is to decouple the concern. So as I showed you, if we make common the deconstruction and packaging as a structural format, and the inverse of taking the structural format and recreating the instance, now we can put anything in between. So anything that takes the structural representation, perhaps creates some sort of JSON or XML or something, or even writes to a file or sends over a network or stores in a database and then reads it back. That's not a concern for marshalling itself. It's up to whomever wants to use it for some purpose. So as you can see here, you have a marshaled point. That's the structural representation of that point. And then on the other side, we can do unmarshal on that marshaled instance and get a point back, and they should equal each other. So this is the, hey, whenever you see this point, see what kind of marshallers and unmarshallers are registered for that point, use the preferred one, and package the object up into this Marshall instance. So this is the structural representation. And in reverse, we're just doing the inverse. We know which schema we used to serialize. We know the structure. We have a descriptor of this structural representation, and we will use that to find a matching constructor and recreate the instance. All right. So this is the current exposed metadata that we're working with. So a Marshall has a schema. A schema, you can think of it as a method signature. And it has an owner type. In this case, it's the point class. We have 2 parameters, so parameter count is 2. The first parameter is an int, and type is an int. The second one is an int as well, so it's an int x and int y. And then we have the parameter name x and y. And if we try to get the values out of this structural representation, the first value should equal to x, right? So that should be 1. And the second one should equal 2, because that's the y value. So we now have something which describes, is sort of like a header of sorts that describes the contents of the Marshall instance. And now we can discuss, okay, so what does that mean? How do we take this Marshall thing and turn it into JSON or XML? So we think about these as generators. They take some in-memory structure and create some external structure. And then I/O is completely separate. You could take that JSON, you can send it over the network or write it to a file. So it's very decoupled in the sense that you could decide whatever you want to do and it's not locked into a single abstraction. So I did a bit of a proof of concept. I've used Jackson in the past, so it's not like I'm a complete novice, but I have never created my own Jackson integration thing. So I took a weekend and thought to myself, how hard can it be, right? And in the end, it was less than 100 lines of code to get Jackson to deal with marshalling. So I could take this JSON string and I could read that as a point or vice versa, create a JSON out of a point. So it's important because you need to have these integrations between different formats in order to have people being able to choose whatever output formats that they want or input formats. So when we decided to decouple this, so some of the design choices are we should have structure as data. So instead of having, if you're familiar with read object and write object, that is structure as operations, because you're saying that the structure is read the int, read the long, etc. But here we are representing the actual structure as data. And interestingly, and we're going to look at this, how does this deal with recursive embeddings of Marshall things? The drawback here is that we don't support cycles out of the box. These are all directed graphs. So the benefits that we get here is that we're wire format agnostic. We don't care about I/O at all. That can be solved on the outside. We can now layer security at multiple different points. We can have extra validation in the object. We can have extra validation as we transform the structural representation into the wire representation. And we can have extra security when we read the wire representation and map that over to the structural representation. So there are multiple points where you can intercept and validate or reject things. And this also means that you can now layer encryption, you can layer compression, you can layer all kinds of things in that was difficult to do before because you had this writer-reader abstraction. So serialization, it's really hard to use correctly. How do we deal with that? I think the simplest way possible to deal with it is really going into simplicity. Few things, already well-known things, and just make sure that there is a clear progression, a clear order to the operations. So the class authors, they're in charge of declaring the entry and exit points of the class and expose those if needed. So they have essentially 3 things that they need to care about: @Marshall, @unmarshall, and the register method if they need to expose things. That's it. Everything else is just maintaining your class and deciding what constructors, what your internal state looks like, your deprecation cycles, etc. And for wire format library authors, what they need to concern themselves with is how do we take instances of Marshall T into whatever representation we're creating, and how do we do the inverse? So they have a few more things that they can deal with. So the marshaled, there are a few utility methods on the marshalling to discover which schemas are registered for the different types so that you can do some sanity checking or picking more specific things. So it's a very small surface area from an API perspective, just compared against Java Serialization. So in essence, when you take, let's say that foo is a marshallable class, bar is a marshallable class, bar takes an int and a foo. When we marshal those, we get a marshaled bar that contains a 5 and a marshaled foo. So that's the recursive decomposition of these things. And then when we recreate it, we just traverse it in reverse, backwards. So we first recreate the foo, and then we pass that into the bar. So it's fairly simple to reason about what happens, and I think that's a huge benefit. One big question might be, okay, so how does marshalling relate to serialization? What is the strategy for migrating? And we haven't decided that yet, but we have found several different paths that we think are promising. So imagine that point here was a serializable class before, and now we want to make sure that, okay, we want to upgrade this, but it still needs to be serializable while we're working in between these things. So we can define our unmarshaller and marshaller. Typically, you already have a constructor somewhere anyway, and then you define the pattern where you extract the state. And then you can actually implement write replace to say, marshal this point. And a marshaled happens to play very well with a read resolve. So whenever you read the marshaled instance, it will turn itself into whatever it represents. So now that provides you with a bridge of taking this instance in the future, serialize it using the marshaled representation, which gives you the safety benefits of records, because you're now recreating this instance using constructors rather than object scraping and constructorless creation. So by making it dead simple, we took these decisions. So have a small surface area, build on top of existing features, no wizardry, no circularity, because that introduces a lot of complexity, and have a clear separation of responsibility. And I think that gives a lot of benefits in terms of it's easy to learn, it's easy to use, it's easy to reuse, it's easy to review. Just looking at, I think I should probably have added a slide of a marshallable class versus a serializable class, and here's a pull request and find one bug. It's much easier to reason about this code because it's code that we've seen for a very long time. This is a constructor, there's an annotation on it. So some key takeaways here. We're trying to reimagine serialization with what we've learned over 30 years. And we want to make sure that the class authors are in control. And we want to represent data using parameter lists because they are easy to reason about. They have an order, they have types, they have names. There's a nice reusability aspect here. You almost invariably have a constructor already. So if you make that marshallable, you know that all construction is going through the exact same validation. So the risk of out-of-sync problems is very, very low. There's some really key responsibility layering. That's also easier to reason about because then you know that I don't deal with compression here. You deal with compression somewhere else. So it's much more easy to reason about where things should go. And you have the opportunity of adding things in layers and not having to bake everything into a single location. And you can have wire formats, as I showed you with my Jackson proof of concept, you can have this common language of marshaled as the building block between different types of wire formats. So I can support both Java Serialization format and JSON in the same VM for the same class. I don't have to bake in the format in the class itself. It's just the structure. So you could have an application that reads objects off of XML and then produces them as JSON. And you can have the same structural representation, but using different wire formats in the same VM. And as we've learned, simplicity takes a lot more effort to achieve than complexity. It's really about choosing which features you support and really making the most of what you decide to support. So what are the next steps here, right? What I have to do is I need to define some sort of initial set of marshalling supported types. We have a pretty big standard library. Should it be a string? Should it be array list? There's a whole host of different classes that may or may not want to be marshallable. We also need to decide what is the preferred migration path from serialization to marshalling. And I have some extra research that I need to do. I need to look into some more advanced use cases like marshalling of method handles. And there's also an interesting possibility here. When you saw that you could take an object and create a marshaled instance of that object, that's a transformation from an instance to a structural representation of that instance, right? But what if we could generalize that so that you don't need to go to marshaled of T, but you could go from instance to anything, because you could think of marshaled as a wire format. It's just that it's an in-memory format. So we're looking at ways that we could go directly from instance to output type. So that's an interesting and promising use case that we're looking into. And then, of course, the hardest thing of everything here is to try to write a JEP about this and see where we take it from there. So how do we get down from the peak here, right? What we've done is we've tried to simplify, remove constraints, remove features, and see what the essence of what we want to expose is. How do we avoid some of the more complicated features and that didn't turn out to be as valuable as we initially thought? I don't know about you, but sometimes a feature that gets used 20% of the time takes 80% of the effort to maintain, etc. And sometimes it's worse. It's 1% of the time value and 99% of the time cost. And if you can, it's always nice to be able to say, okay, this is not a feature that is worth it. So when we look at this, marshalling is like, oh, it's a constructor and it's a deconstructor and now we're done. What took you so long, right? But it took a very long time to figure out what are the features that are risky, costly, hard to maintain, and what are their implications on other things like maintainability, evolvability of the language, etc. So the current implementation of marshalling, my proof of concept, is around 1,000 lines of Java. Including Javadoc, license, everything. So it's a very simple thing to implement. And I can guarantee you that Java serialization is more than 1,000 lines of code. So by restricting the features, we can also arrive at a very much simpler thing to maintain as well. Thank you for showing up. It's always nice to see other fellow serialization aficionados. So catch me around the conference. And I think we have time for 1 minute worth of questions. Otherwise, just try to find me in the hallway and feel free. Yes.
Hi, hello. How do you deal with fields which are not passed to the constructor? Like, for example, when your point class had a timestamp field which would be set in the constructor. Can
Yes.
you serialize that or not?
Yeah, so how do you deal with data that is either derived data from other fields or it's effectful data, like reading the clock or something like that? Well, it's easy because if you have a constructor that doesn't have that value, you could still have a constructor that is private that does expose that value. Because you would want to, well, it depends on your use case, but I was presuming that you want to preserve that timestamp so that when you recreate it, it has the same timestamp. But the good thing here is you can have different constructor for your typical developer audience, and you can have other constructors that are just for marshalling, saying that this is a part of my external contract. It's not the preferred entry for your typical use cases, but this is strictly intended for this. So you have a choice of either exposing it, if that's fine, or just having it as, hey, I register this with a private constructor and it's only marshalling that needs to deal with this. Okay.
So you're going to give us standard marshalers for lists, maps, optional, and all of that?
So the question is whether I am going to provide you with standard marshalers for all of these. It's a great question. And it also depends on what you want to preserve. So imagine, for instance, an array list. When you marshal that, do you want to marshal things like its capacity? You might not want to, but someone else might. So that's one of the big things to do, which is deciding what is the external contract of this thing and should those be maintained. The good thing, though, is that since there is a translation from marshaled to the wire format, it's possible to add more information or remove information on the way, or even translate and say, oh, when you try to serialize an array list, I know how to do that. I will pick out the values that I want to, and I will send that over. So you could have the equivalent of a read, resolve, and write, replace anyway, but you don't have to put it in the actual class. You can actually layer it in. So it allows more sophisticated use cases, but it's a great question, which is what information should be preserved and exposed, which is definitely something that I need to find who's responsible for array list, right? So that we're sure that the external format is what it is. But you could also say that, hey, you should preserve all the same data that is preserved by Java Serialization today, which could be a valid choice. So it's a lot of work to go through and look at all these. But the important part here is that it's not a closed set of things. So when we marshal things, we only recursively marshal things that are marshalable. And if they aren't marshalable, we leave them as they are. So you could end up with a list that has an int, a string, and an array list if there is no way that array list has said, this is how I want to be marshaled. So that allows us to gradually extend the number of types that have their own marshalers. Otherwise, it would be more of a big bang release sort of. Yes?
Maybe I missed something, but supposing, if you always go through a constructor to reconstruct the object, what about kind of singleton cases where, it's a simple example.
That's perfect question. All right, so the question is, how do we deal with singletons or even things like enums, right? How do we deal with that if they always have to go through constructors? Well, the interesting case here is that, and I probably just briefly mentioned it or should have put more emphasis on it, we also support annotating static factories. So that allows us to, if you have an enum, you could go and have basically for name lookup on the name of the type, or even for singletons, there's a static factory that doesn't take any parameters, that just returns the instance. So the only thing that you need to retain for a singleton type is its type name, if there's a singleton per the class. So it allows us, and I have a pretty vast library of different use cases of both inheritance hierarchies and singletons and enums and all kinds of things. And it's really simple to model things as constructors and static factories. So it's a pretty interesting piece of functionality. All right. Have a great conference.